Welcome to tutorial number 7. In this tutorial I'm going to show you guys what self-attraction and repulsion is and how it works. So self-attraction and repulsion attributes generate attractive and repulsive forces between voxels in 2D or 3D fluid containers. Using the self-force attributes, you can set whether the forces depend on the container density or temperature grid values. Okay, you can set whether you want the forces to depend on the temperature or the density. On the other hand, this bad boy right here, let me just turn this guy to density. Now this bad boy right here, equilibrium value attributes, sets the target, which determines whether a voxel would generate an attractive or repulsive force. So this one is pretty much like your parents. If your parents are ugly, you're gonna be ugly. If your parents are handsome, if your parents are good looking, there's a high chance that you're gonna be good looking, you know? That's what that is. But anyway, that's besides the point. So voxels with density or temperature values less than this bad boy right here will generate an attractive force, while voxels with density or temperature values greater than this equilibrium value will generate a repulsive force. So it's sort of a balance, you know. If it's less, it will generate an attractive. If it's more, it will generate a repulsive. Okay, that's what it is. So when this bad boy is set to 0, okay, when self force is set to 0, no self force will be applied to the voxels in the fluid container. When it's set to density, this one sets the self force to be based on the density grid values. When it's set to temperature, it sets the self force to be based on the temperature grid values. Alright, so self-attract. Self-attract sets the strength of the attractive force. Self-attract does not, and always remember, self-attract does not affect voxels that have density or temperature values greater than equilibrium values. Okay. Self-repel, this one right here. Self-repel sets the strength of the repulsive force. Self-repel does not affect voxels that have a density or temperature values less than equilibrium value. Remember that too, it makes sense. Equilibrium value, which is this bad boy right about here, 0.5. This equilibrium value sets the target value that determines whether voxels generate an attractive or repulsive force. Remember, I said the equilibrium. Look at equilibrium value as your parent. It sets whether you're going to be good looking or average looking, because there's no such thing as bad looking. You know, another man's dinner is another man's poison. So that's how it goes. So voxels that have density or temperature values that are less than the set equilibrium value will generate an attractive force. Voxels with density or temperature values greater than the equilibrium value will generate a repulsive force. Okay, remember that. Self-force distance right now is set at 16. So this one sets the maximum distance in voxels that the self-force is applied. For example, when set to 1, voxels are only affected by the self-force generated by the voxels next to them. So if the self-force distance value is greater than the resolution of the fluid, each voxel in the container is attracted or repelled by every other voxel in the fluid. The fluid value for self-force distance is usually 16, and right now it's set at 16. Okay, large self-force distance values can increase simulation time, so you can use up it can also use up your memory and stuff like that, and you don't want that. So if you increase the resolution in a fluid container, increase the self-force distance value to obtain the same effect. Otherwise, there will be no difference. The effect of self-force drops with the local space distance in a way that is similar to gravitational self-attraction. And again, it will make more sense later on, but you just need to know what it is. Okay, I hope you've understood, guys. I couldn't show anything right here because there's nothing proper to see. There's just smoke. So when I start making simulations like fire or whatever, you're gonna see me come back to these attributes a lot, and I mean a lot, to change not render, but I use the IPR. So this bad boy, sorry, I'm used to saying bad boy, but anyway, I use the IPR so it sort of updates updates in real time, and I'll show you. I've already told you guys how to use the IPR, but if you've forgotten, I'll still show you again later on when I start doing that. So anyway, I'll see you in the next tutorial.